So this is our third video on conditional probability in the multiplication rule, section 4.3. And we want to generalize the multiplication rule. Let's say we had three events, A, B, and C, and we wanted to find the probability of A and B and C. All three of them happening. All three of them happening. So to generalize the multiplication rule, you'd start off with the probability of A, be this right here, multiplied by the probability of B, given that A has already happened, times the probability of C, given that A and B have already happened in the past. This is called the generalization of the multiplication rule. It is the multiplication rule, but generalized to three events. And you can do it for 4 events and 5 events and as many events as you want. So we want to do a few problems involving involving 3 events. So let's say you got 3 cards that are drawn from a deck of 52 playing cards. 3 cards are taken out of a deck. No replacement. No replacement. So we're going to take out a card, leave it out, take out another card, leave it out, and take out a third card. So we're never going to put any cards back in. You're going to start out with 52 cards, and you're going to go down to 51 cards, and you're going to go down to 50 cards, right? All right, so here we go. Determine the probability of getting a king, a queen, and a jack. So probability of getting a king and a queen and a jack. All 3. That's all I know. 3 draws without replacement. So first focus on the probability of getting a king. And then multiply by the probability of getting a queen, given you've gotten a king already. You could say after you've gotten a king already in this context. Times. Use purple. Times the probability that you get a jack after you've gotten a king and a queen. All right, so focus here on the green. What's the probability of getting a king? This would be like on the first draw, right? You got 4 kings out of 52 cards. So your probability would be 4 out of 52. Okay, now you're going to multiply. Multiply. We're doing all these ands, right? King and queen and jack. So you're going to multiply. Use the multiplication rule. So multiply. What's the probability of getting a queen after you got a king on the first draw? So how many queens are in the deck? Still 4, right? Now how many total cards are in the deck? Notice we got a king. We're assuming we got a king here, right? This is a given that we got a king. That's a given. So you got that king on the first draw. And remember, you're not replacing cards. You're not putting cards back in the deck. So that card stays out. So you only got 51 cards. 51 cards in the deck. So 4 out of 51 is your chance of getting a queen on the second draw after you got a king. Okay, and finally, we're going to use the multiplication again. Probability of getting a jack after you got a king and a queen. What's the probability of getting a jack? You got a king on the first draw, a queen on the second draw. Probability of getting a jack is going to be 4 out of 50, right? Why 50 cards? Because here we're given, right, this is assumed, we're given that we got a king and a queen. A king and a queen, so we're taking those cards out, the king and the queen. And you take them out, you leave them out, there are only 50 cards remaining. But you still have 4 jacks, right? 4 out of 50 is your probability there. So if you multiply these together on top, you got what? 4, 4, 4. 4 times 4 times 4 is 64. Out of a total of, multiply 52 times 51 times 50. 52 times 51 times 50. 132,600. So we're going to turn this into a decimal. That's the way we always write our probabilities as decimals. 64 divided by 132, 600. It's, so normally I take just 3 decimal places, or if not 3, maybe 4, but this time I'm going to take it to 5 because it's such a small decimal point. 0.00048. If you wanted to take it to 4 decimal places and just write 0.0005, that would be fine, but you want to take it at least to 4 decimal places since this is such a tiny decimal. Okay. So next problem, we want to find the probability of getting a face card, an ace of spades, and an ace. Probability of a face card. Let me get rid of this comma here. I'm going to say and. Use the word and, so we know we're talking about an and situation. Ace of spades and an ace. So if we're using the multiplication rule, which is appropriate here, you got the probability of a face card. Multiply it by the probability of an ace of spades, given that you got a face card on the first go around. And then you're going to multiply by the probability that you get an ace, given that you got a face card and an ace of spades on the first and second go around. Okay, so what's the probability of getting a face card? This is assuming the first go around. You got how many face cards? 12 out of 52 cards. That's on the first go around, first draw. All right. So now we're on the second draw. What's the probability of getting an ace of spades after we already get a face card on the first draw, given that we got a face card in the first draw? Well, there's still going to be just one ace of spades in the deck, right? There's only ever one ace of spades in the deck. And that's going to be out of how many cards? 51, right? Why 51? Because here we're assuming that we got a face card on the first draw, and that card goes out of the deck, and it doesn't go back in. It's not replaced. There's only 51 cards remaining. All right, now we're going to multiply. What's the probability of getting an ace after you get a face card and an ace of spades? There are going to be only 3 aces left, right? 3 aces. Why 3 aces? Because you got a face card and an ace of spades. So that ace of spades that you get, you assume you get, right? Okay, underline that. So you get a face card and an ace of spades on the first and second draws. So when you take that ace of spades out of the deck, you only have 3 aces remaining. And how many cards in total do we have? 50. Right, 50, because you took out the face card and the ace of spades. You multiply these together. The tops multiply together. 12 times 1 times 3, that's 36. And we know what the bottoms multiply to be. 52 times 51 times 50. 132,600. Let's divide this out and find approximately what it is. Okay, I'm going to take this to, again, 5 decimal places because it's so tiny. 0.00027. If you wanted to take that to 4 decimal places, you could, and say 0.0003, you could. I'm going to take it to 5 just because it's so small. All right, here's a number 3. What's the probability of getting 3 kings? Now let's do 3 queens. 3 queens. All right. That's the probability of getting what? A queen and a queen and a queen. Okay, so first go around, probability of getting a queen. Times, using the multiplication rule, you write probability of getting a queen. Given that, you already got a queen on the first draw. And then finally, multiply by the probability of getting a queen. Given that, or after that, you got queens on the first and second draw. So queen and a queen. Squeezing that in there. Okay, so in green, I'm thinking about my first go around. What's the probability of getting a queen? 4 out of 52, right, on the first draw. 4 queens out of 52 total cards. Okay, so now we're on the second go around. What's the probability of getting a queen, given that we've already got a queen on the first draw? So how many queens are left in the deck if you assume that you got a queen on the first draw and that queen comes out, right? We're not replacing cards, we're leaving them out. There are actually only going to be 3 queens left in the deck, right? Out of a total of 51 cards, right? Because you take that queen out, there are only 51 cards. All right, so now we're going to do that purplish color. What's the probability of getting a queen after you got a queen and a queen already? Well, how many queens are left in the deck? Remember, you're assuming that you got a queen and a queen already. That's a given. That means you have 2 queens left in the deck, right? You got one on the first draw, you got one on the second draw. So there are only 2 queens left in the deck. And how many cards total? 50. Total of 50, because you got those 2 queens out of the deck, left out. So we got what? 4 times 3 times 2. That's 24. Out of a total of 52 times 51 times 50, multiplying these together, 132,600. Divide that out. What happens when I divide that out? 24 divided by 132,600. Get a decimal. Really small decimal. I'm going to go to 5 decimal places. 0.00018. So if you want to go to 4, you could say 0.0002 if you wanted to. I'm going to go to 5 because it's such a tiny decimal. All right, so these are more straightforward. These first 3. Here's a challenge problem. Number 4 is a challenge problem. I'll put a little star by this. This is a challenge problem. So remember, we're drawing 3 cards out of the deck. And we're not putting any cards back. What's the probability at least 1 card is black? At least 1 card is black. So what's the probability of getting at least 1 black card? Probability of at least 1 black. Just think about that. If you're getting at least 1 black, at least one of your cards is black. That means they're not all red, right? This is the same thing as not all red. Probability of getting not 3 reds, right? So if you have at least 1 black card, that means they're not all red, not 3 reds. In other words, you could write it this way. Probability of not, so this bar here, remember, it's called the complement bar. That means not red and red and red. So not getting all reds. That's called the complement, that bar there. It means not. So that's the same thing. Remember, the complement rule is 1 minus the probability of the event, which is here, red and red and red. 1 minus the probability of getting red and red and red. All right, so I'm going to have here 1 minus, so we're going to focus on the probability of getting here red and red and red. So we'll start with green. That's the probability of getting red using the multiplication rule times the probability of getting red, given that I got a red the first time, times the probability that I get red, given that I got red the first and second times. All right, so that's going to be what? 1 minus, what's the probability of getting red on a single draw? Single draw, let's say the first draw. Well, you got 26 reds out of 52 cards. All right, we're going to multiply that by, what's the probability of getting red on the second draw, given that you already got red on the first draw? Well, how many reds do you have remaining in the deck? You got 25, right? 25 reds remaining in the deck, because we're assuming we already got 1 red, and that comes out. 25 reds out of a total of only 51 cards, right? Because we took that red card out that we got on the first draw. And then you're going to multiply this by the probability of getting a red after you've gotten a red and a red already on the first and second draws. Okay, so the question is, how many reds do you have in your deck? You got 1 out in the first draw. You got 1 out in the second draw. So that means you got 24 red cards left in your deck out of a total of only 50 cards, right? 50 cards, because you got 2 reds out. Okay, so we're going to have here 1 minus, we're going to multiply these together, 26, 25, 24. What happens when you multiply those guys together? 26 times 25 times 24, multiplication. You're going to get 15,600 divided by the denominators when you multiply those together. That's 132,600. 132,600. Yep. So we got 1 minus. Okay, let's make an approximately simple here. We're going to do the decimalization of our fraction. Let's take 15,600 divided by 132,600. Our calculator, get a decimal. It's going to be approximately, let's go to 3 decimal places. 0.118. And when we subtract this, 1 minus 0.118. This is about 0.882. So roughly a 88% chance of getting at least 1 black card. In other words, not getting all red. Okay, I think that does it for this video. That's a challenge problem right there.